The facade is the most visible component of a building. One could call it its outer skin. The facade is a crucial topic for architects and building engineers, not only because it determines the building's appearance, but also because it performs essential functions. It determines the visual aesthetic of the building and also serves as its protective hull. It is called upon to protect against the potentially damaging effects of the elements, to help conserve energy, insulate against noise, regulate the building's climate, and provide protection against corrosion and wear, while allowing for optimal air circulation and diffusion of water vapor. All of these functions can be very well performed by ceramic facades. Many famous examples around the world bear witness to the timelessness and toughness of ceramic facades. The Ishtar Gate of ancient Babylon was built around 580 BC. The Colosseum in Rome was built in 80 AD. And the papal retreat Castello San Angelo was built in the year 139. The Cathedral of Bad Doberan was built in northern German brick Gothic style in 1368. While this church in Berlin dates to 1835 and was designed by the famous architect Carl Friedrich Schinkel. The German Museum of Applied Art was built in 1881. These historical terracotta facades are just a few of the many buildings still standing today, such as this one built in 1880 in the United States. Or this contemporary building made of architectural ceramic, the Davis Center in Berlin. The ecologically friendly raw material for this architectural ceramic, clay, is strip mined with the help of excavators or wheel-mounted front-end loaders. After being excavated, it is pre-crushed, then ground and homogenized in pug mills and rolling mills. Using a vacuum press, the clay is pressed through a die to form a continuous filament that is then cut, dried in drying chambers, and fired at temperatures of about 1,000 to 1,200 degrees centigrade. The result is architectural terracotta in various shapes, colors, surfaces, and sizes. Architectural ceramics exhibit the following characteristics. They retain their shape. They are resistant to cold. They are highly resistant to chemicals. They are very rigid and hard. They can withstand ultraviolet light and do not lose their color. They are absolutely resistant to corrosion. They can store heat and serve as insulation. They keep out noise. They require little or no maintenance. They are economical because they can be mounted and assembled quickly, especially in the case of large facade elements. They are absolutely free of hazardous substances, are ecologically friendly, and can be recycled. One of the world's leading producers of architectural ceramics for back-ventilated facades is Nbk, headquartered in Emmerich, Germany, with additional offices in Cologne, Berlin, and the United States. The city of Emmerich lies near the western border of Germany. This is where the production facilities of Nbk, the Niederrheinische Baukeramik Company, can be found, in a beautiful location on the bank of the River Rhine. The company specializes in the manufacturing of innovative facade ceramics to meet the highest demands. We'd like to take you on a tour of our plant and show you the products that we make here.
Guten Tag. Ich heiße Sie recht herzlich willkommen auf dem Werksgelände.
Hello and welcome to the production facilities of Nbk, the Niederrheinische Baukeramik Company here on the Lower Rhine. Nbk is a more than 100-year-old family company, which specializes in the production of high-quality facade ceramics. Nbk is global leader in custom-made facade ceramics. We export our products to 60 countries around the world. This film should provide you with a glimpse of the technical and design capabilities of our company. First, Choice selections of clay are mixed together and pre-processed in state-of-the-art facilities. Then the material is pressed into the desired shape using high-precision extrusion molding equipment. Once the clay has been pressed through the die, it is cut to the desired length. All of these processes are electronically monitored and steered by computers. In drying chambers, water is removed from the ceramic blanks and they are prepared for subsequent firing. In special kilns constructed exclusively for our products, the clay panels are fired for 12 to 48 hours at temperatures of up to 1200 degrees Celsius. And this is the result. In our in-house certified laboratories, the products are inspected and quality checked according to a number of standards, including water absorption, gross density, resistance to cold, scratch resistance, dimensions, tolerances, and bending strength. These tests are carried out in accordance with European and American standards. In addition to external auditing laboratories, we employ our own in-house labs for testing and development. Here, colors and materials are being mixed to meet customer specifications. We are capable of creating nearly any surface in any color. Once the material has passed the quality checks, the tile elements can be packaged for delivery to the customer. Depending on the type of transport, whether truck or container, the ceramics are stacked on pallets and shrink-wrapped or surrounded with styrofoam and packed in overseas shipping crates. Safely wrapped, the materials are delivered to construction sites just in time to meet optimal logistical requirements. In case of long-distance or overseas shipments, especially to the United States, the terracotta is transported in economical and ecologically friendly container ships from the container port in Emmerich or the Hamburg seaport. Change of scenery. Architects, construction designers, structural engineers, and contractors meet in our seminar and exhibition center to discuss new projects in a relaxed atmosphere and examine new materials, shapes, colors, and modern facade techniques and technologies. Depending on the architectural requirements, different product lines are used. This is the mid-size hollow chamber element with a maximum length of 1,200 millimeters. These panels are available in widths of up to 300 millimeters. The thickness of these relatively lightweight panels is limited to 30 millimeters. The large format, with a maximum length of 1,800 millimeters and maximum width of 600 millimeters, is probably the most commonly used large-scale hollow chamber element. The thickness is 40 millimeters. The solid ceramic element is available in lengths of up to 1,200 millimeters and widths of up to 600 millimeters. It is primarily used in prefabricated concrete facades. It's available in thicknesses of 20 or 30 millimeters as desired. And finally, there is the standard ceramic shingle with a maximum length of 1,800 millimeters and a width of 600 millimeters. Also a hollow chamber element. It's available in incremental thicknesses between 20 and 40 millimeters. The range of standard Nbk products includes an individual product format that can be adapted to the dimensions of the building layout. In addition, this facade element can be produced as a hollow chamber element with various surfaces and textures and profiles. The TerArt range of products offers numerous additional special formats and innovations to give buildings an individual appearance. For example, elements with varying radiuses can be produced to create elliptical shapes. TerArt baguettes are square tubes available in various sizes, from a minimum cross-section of 5 by 5 centimeters and with a maximum length of 180 centimeters. Round and oval forms can also be manufactured. They are clever and sophisticated building components that afford architects virtually unlimited design possibilities. The surfaces of the ceramic panels are normally fired at up to 1200 degrees Celsius and sintered, making them extremely durable and able to withstand the elements. They are available in nearly any desired color and can be customized in a number of ways. Polished and honed surfaces are available, for example, that excellently highlight the structure of the chamotte grain in the clay mixture. Glazed elements provide particularly unusual surfaces and intense colors. Terre art glazes are being used more and more frequently in contemporary architecture. Nearly any color and surface texture is possible. One-of-a-kind signature facades make today's buildings truly unique. According to your specifications, our planning engineers develop Terre art ceramic facades exclusively for your structures, including detailed planning for the construction site and assembly. The basis for Terre art facade construction is a suspended back-ventilated ceramic shell mounted on a thermally separated aluminum subgirt. This is the metal stud wall system that is primarily used in the Scandinavian countries and North America. Vertical fiber reinforced construction panel, elastomeric protective membrane, horizontal aluminum carrier extrusion, adjustable angle bracket, vertical carrier extrusion, semi-rigid or rigid heat insulation, clips to hold the panels in place, and the Terre art ceramic panel. Here is the horizontal cross-section in detail. This is an optional joint trim to ensure precise vertical alignment of joints. Here is another example of the execution of the construction work shown in detail. A special film is applied to the fiber construction panels screwed onto the metal brackets. A metal finder can be used to locate the metal brackets behind the facade so that the horizontal fastening rails can be attached in a grid system. These are the angle brackets with thermal spacers, which can also be attached at regular intervals in the grid system. Now the vertical profile carriers are mounted. Then the support structure is complete, with lattices running the entire length of the panels and calculated to support the weight of the terracotta facade. Now the heat insulation can be applied. Synthetic fastening bands ensure precise fitting. Finally, the ceramic panels are simply hung on the patented Nbk fastening clips. Each panel is held by a clip at the top as well. Few components, fast assembly, and complete safety are the characteristic benefits of the Nbk system. All that remains to be done now is the fitting of the optional joint trim elements to ensure the perfect positioning of the panels. That's all there is to it. The insulated back-ventilated ceramic facade is in place. And this is a conventional building with a facade mounted in this way. On solid block or concrete wall systems, the assembly is mounted as follows: massive local wall, fixed point bracket with thermal spacing, vertical profile, insulation, fastening clip to hold the panel, PVC joint trim, Terart ceramic panel. Let's take a look at how it would be assembled. First, the holes are bored for the fixed and adjustable brackets. Molly bolts or anchors are inserted as required, depending on the construction material. The adjustable bracket on the vertical carrier extrusion allows for back ventilation. The fixed bracket also allows for back ventilation and thermal insulation. The vertical profile made of extruded aluminum, with pre-bored holes for the panel retainer clips at regular intervals. With special self-tapping screws, the vertical profile is fastened to the bracket. Now it's time to bore the fastening bolts for the heat insulation. The grooved panel is hung onto the vertical carrier extrusion. The panel retaining clips are fastened and the panels are hung. Finished. The facade can be completed in a very short time. Here's another building with a facade that was mounted in this way. Another variant of the Terart facade system is the Terracotta precast concrete system. In this factory for precast units in Liverpool, England, the casing is produced for the component. The ceramic panels are inserted into the casing as shown in the architectural drawings and form the subsequent outer shell of the building. The joints are sealed with gaskets. Afterwards, the steel reinforcements are put in place and the concrete is poured. Once the concrete has hardened, the outer shell is attached. Now it's possible to attach the prefabricated components to the facade quickly and easily as they are delivered by truck. An example for a building using this assembly technique is the Princess Dock Car Park in Liverpool. The British trade publication British Precast featured this building on the first page of its annual review in 2005. Another important system for attaching prefabricated facades is the terracotta unitized curtain wall. Here, the components are hung like a curtain and attached to the structure. The skeleton comprises an aluminum frame construction spanning the height of the story, shown here in cross-section. The heat insulation is a sealed cavity. The metal plate seals off the insulated area from the rear ventilation. The Terart Architectural Terracotta panel. The story-high elements are completely prefabricated at the plant, so they can later be installed more quickly. Here you can see the retaining clips being fastened to the vertical carrier extrusions. After that comes the heat insulation. The type and thickness of the insulating material can be freely specified. The hollow chamber is filled with the insulating material and sealed off with sheet metal. Now, following a precise measurement process, the terracotta panels can be hung on the structural elements. In the shortest possible length of time, the architectural terracotta panels have been attached to the story-high structural elements. The building components are stacked in collecting bins and packaged for transport to the construction site. Another scene change. 7 o'clock in the morning at a construction site in downtown Hamburg. An office building with more than 20 stories is to receive its suspended facade made of glass and terre art ceramic panels. The architects had 3 primary tasks to fulfill. Assembly must be carried out quickly, and space is at a premium on the crowded downtown site. In addition to the glass windows, an unusual facade material will be used to give the building a unique appearance. The material must be very durable and provide optimal protection against external influences over a long period of time. The solution was a suspended facade using ceramics with a variety of surfaces, colors, and formats. A crane lifts the building component to the 8th floor, where it will be mounted onto the support structure. The component arrives, and it's directed into the pre-mounted carrier brackets using walkie-talkies. Finished. Another building component mounted in no time at all. This is what the Astra Tower in Hamburg will look like once it's finished. All around the globe, in more than 60 countries, buildings with terre art ceramic facades grace the urban landscape. Terre art ceramics open up whole new worlds of possibilities for sophisticated and attractive facade design in a multitude of shapes, colors, and surface textures. Winning advantage through variety. That's the motto of Nbk Ceramics Works.